Um, well, thanks for the kind introduction and the invite to be here today. I have seen a couple of the talks as part of this series over the years, so it's cool to be invited and share more about the work that I'm helping lead with the Kashia Band of Pomo Indians. And we'll be launching into who the Kashia are and what the work's all about in a second. But just before we do, I want to just introduce myself. Um, as was mentioned, my name's Dan Swezey. Oops, hold on a second. Let me get this little window out of the way. My name is Dan Swezey, and I'm the Director for Oceans and Aquaculture. For the Kashia Band of Pomo Indians, I help lead marine conservation and aquaculture development projects for the tribe that we'll be talking about here in the presentation. And before we launch into the meat of everything, I just want to acknowledge all the tribal staff that have contributed to the work I'm going to be sharing today. And these are staff in Kashia's environmental department. There have been many other folks on the leadership side and in the tribal government that have also helped all this work be born and come to be that I don't have time to fully acknowledge today. But I just want to acknowledge these folks because they're direct contributors. Eli Scott, Colin Carney to Kashia Tribal Divers, Nina Hapner, who's the tribe's director for environmental planning and natural resources, my boss at the tribe. And none of this would be happening without her hard work and dedication to these ideas as well. Abby Gomes, senior environmental technician with the tribe. Chris Elliott, Array LaRose, two new tribal divers that were trained this summer, and Brian Piantanita, who's the tribe's dive coordinator, and Meyer Munsterman, who was a technician for the tribe, working for the tribe last year and this year. And she's a PhD student at UC Berkeley. So just a few of the people that have helped this all come to be that I want to acknowledge before we launch in here. So you may be asking yourself, who are the Kashia? Kashia Band of Pomo Indians, and in short, the Kashia are the indigenous peoples of the Sonoma Coast, the first inhabitants of this region of coastline that we now call coastal Sonoma County, having lived on this stretch of coastline for well over 12,000 years. And on the left here, you see an image of Kashia's ancestral territory, which extended from Bodega Bay in the south all the way up to the Wallala River in the north and some 30 miles inland. And also featured on this map are these blue dots, which are historic Kashia village sites in the territory. And what I want to kind of draw your eye to is all of the coastal village sites that were located up and down the Sonoma coast where the Kashia people lived for millennia. And I want to emphasize that the Kashia people are to this day and always have been a very ocean-facing, ocean-connected people. Traditionally, the tribes people move from inland territories to the coast seasonally every year to access resources that were available in those locations. And that access to the coast and that connection to the coast, including powerful connections to essential resources like seaweed, shellfish, diversity of fish species on the Sonoma coast, and marine mammals historically, really were at the core of the tribe's history, culture, and identity, and still are to this day, and really underlie the tribal community's health and well-being. So the Kashia have a very deep connection to this place that we now call coastal Sonoma County. And I want to tell just a little bit of history before we kind of get into the science and talk about kelp forests and what's been happening. Because I think this history is important, and it does, in many ways, is connected to what we're seeing in the ecology of the system now, which has kind of been 200 years in the making. So it's important to highlight this because the Kashia people have been directly involved and directly impacted by these events. So in 1809, some of you may know this history, some of you may not. In 1809, Russian fur trappers arrived in Kashia territory looking to hunt sea otters, fur seals, and to grow food for Russian colonies abroad. And in 1812, they established what's called Fort Ross today, kind of an anglicized version of Fort Rus, which just meant the Russian fort, at a Kashia village site called Matini, which was an incredibly important Kashia village where many hundreds of Kashia people lived. And the Kashia gave permission for the Russians to build this fort on this stretch of coastline. And as the story goes, the 24 Russians arrived with 100 Alaskan otter hunters and native men from Alaska and Hawaii that built Fort Ross at the Kashia village side of Matini. And for those of you that may not be as familiar with the history, in the late 1700s, early 1800s, the Russians had a huge enterprise and colonies all over, mostly Alaska, hunting sea otters for sale back to Asia, where wealthy buyers were paying a lot of money for pelts and jackets and clothing made out of otter fur, which was considered an extreme luxury item. This was called the Trans-Pacific Fur Trade, and the Russians had a huge presence in Alaska and kind of a colonial presence. These are all kind of colonies and forts that was dedicated to exploiting this resource. And I recently learned that they also had a colony on the island of Kauai in Hawaii, and at this period of time had plans to annex the Hawaiian Islands and make it part of the Russian Empire. So that's why Hawaiians, in addition to Alaskans, were also brought to Kashia territory to help build Fort Ross. So very complex and interesting history. That there's a lot more to say about that, but time is short today, so just giving you little flavors of this. This is a drawing of Fort Ross from that period of time, the early 1800s. And what I want to emphasize is that this is a kind of anthropological work that's been done on this, showing this was the fort here in the square, and there was kind of a Russian neighborhood, there was a Native Alaskan neighborhood, and then very importantly, there was a massive Native California neighborhood. Hundreds of Kashia peoples and actually other indigenous peoples were living at and around this location before the Russians came and after the Russians came, and have and to this day have a very powerful connection to this place. This is Fort Ross Cove here and Fort Ross Creek, where a lot of salmon and other resources were fished. So just want to emphasize that this place, we kind of remember it today as kind of this Russian fort, but it actually has been sacred Kashia land for many millennia and is still a sacred place to the tribe today. And so just kind of some images showing the hunting of sea otters. The Russians brought with them Alaskan expert hunters who probably were in different situations of debt or servitude, probably weren't exactly here totally 100% on their own will. But they were here and they were very effective at hunting sea otters. This is the docent at Fort Ross, if any of you have ever been there, kind of showing sea otter pelts and talking about what this trade was all about. So we're going to kind of go to this part of the talk that I call 200 years of history in 2 minutes, because it's what the time we have today. So we're kind of 1809, the Russians arrived. By 1840, the sea otters had been hunted to near extinction. And I was recently talking with the Kashia tribe's historic preservation officer. And the Kashia history that is taught is that at this point in time, around 1840, the Kashia asked the Russians to stop hunting the sea otters, and that this resource was critical to Kashia culture and Kashia lifeways, and that the tribe knew that this resource was disappearing. Oh, hold on a second. I'll be right back. Oh, sorry for that interruption. There's a bunch of noise that was about to come through. 1847, moving along here, the sea otters had been hunted to pretty much complete extinction, and the Russians decided to depart back to Russia. And so this was a huge change. And I've learned recently, these are kind of pictures of what the otter pelts look like in Alaska at the period of time, but that the sea otters were incredibly important to the Kashia people for a number of cultural reasons, and kind of a very powerful connection, actually, the Kashia had to this. This is a depiction of two Kashia hunters from the period, and they have these sea otter wraps, kind of hats that had tremendous sacred meaning and connection to many powerful stories with the Kashia people. And this resource was lost. Really within 30 years, the sea otters had been hunted to extinction. in Kashia territory, and not just Kashia territory. The Russians also hunted them to extinction on the entire Mendocino coastline. They went up the coast and were very effective hunters, depleting this resource. So this was a huge change that is something we're still catching up to today. And I'm sure most of the folks on the call today probably know that sea otters have an incredibly important role in kelp forest ecosystems. This is a sea otter in Monterey. They eat a diversity of different prey items and shellfish, and this is a picture of an otter eating purple sea urchins. And this is a very well-established relationship all around the world, that sea otters are these voracious predators, and they control kind of the herbivore resource, which in turn permits the kind of basal kelp forest ecosystem to thrive when the pressure of the herbivores is reduced because of the predation of the otters. So this is super well established all over the world, California coast, Alaska, and any other places where you have otters and kelp forests. This is a pretty well understood relationship. So the loss of the sea otters really is the precursor to what's been playing out on the North Coast in recent years, and when this major predator was lost. So moving forward in time, and this is, some of the harder stuff to talk about in this presentation, but I think it's important because it does kind of paint the picture of what this work is all about in some ways. 1849, the gold rush started in California and brought a massive influx of settlers to the state, hundreds of thousands of people coming really from all over the world, looking to make their fortunes and claim land in the state of California. 1850, California became the 31st state in the Union. And in 1856, there's really no way to sugarcoat this, but this was the beginning of the California Indian genocide in more recent times. The state legalized the genocide of indigenous peoples and offered payments to settlers for eliminating California's indigenous peoples on desirable lands. This really was, in my opinion, probably the darkest period of history in the state of California. I certainly didn't learn very much about this, being a lifelong California resident. Really there's so much to say about this that we don't have time for today, but this was a period of tremendous darkness, not just for the Kashia, but for all of California's indigenous peoples. Up to this point, the Russians were the only Europeans the tribe had interacted with, and the massive influx of settlers that brought with them violence and a lot of darkness is still something that we're all dealing with here in the state of California. And despite this kind of huge period of darkness and adversity, actually, the Kashia people actually at this time were forced to reservations in further north in Northern California, one of them being the Mendocino Indian Reservation that was located where the town of Fort Bragg is today, which was essentially a concentration camp for indigenous peoples from the northern part of the state. The Kashia resisted this deportation and all the things that were happening, and protected their culture in hiding, and survived in the land that they knew, the isolated hills of coastal Sonoma County, where their culture survived to this day. And in 1916, the federal government re-recognized the tribe and helped to establish the current Stewart's Point Rancheria, which you can see here on the map. But the big take home, and there's a lot more history in all of this that I just don't have time to go into, is that for well over 150 years, Kashia's had close to no say over the management of marine resources that had sustained the tribe since time immemorial. And that's a big thrust of the work we're trying to do today. So it's not all total darkness. In 2015, the tribe had first coastal land returned to it. This is a 1 mile stretch of coastline immediately north of Salt Point State Park. And this was 700 acres of land returned to the tribe, and 12,500 years of Kashia history on this land, many important Kashia cultural sites on this land. And importantly, this was the first time that the tribe was afforded access to the coast and could access those marine resources and have that connection to the coast that they've always had without having to ask permission from a private landowner to access the coast and the coastline that they've always been a part of. So it was incredibly important from a lot of different perspectives. And the tribe now operates a marine reserve on this 1 mile stretch of coastline and a terrestrial reserve as well. So this was an incredibly important event, and hopefully just the first of many land returns to the tribe. Obviously, the tribe had a vast territory, and this is just a 1 mile stretch of coast in its territory, and hopefully the first and not the last coastal land return to the tribe. And the connection to kind of what then happened is pretty profound. So right at the same period of time, 2014, 2015, as I'm sure most people on the call today know, the California coast experienced a record-breaking marine heat wave, and we now call this and refer to it retrospectively as the warm blob. This was kind of a record-breaking event, not just in terms of the temperatures reached, but also kind of how persistent this event was. And it lasted for 3 years. This is a map showing sea surface temperature anomaly, darker colors kind of indicating persistent difference from normal during this event. So, this is in essence degrees Celsius. So we were 3 degrees Celsius, that's about 6 degrees Fahrenheit warmer than normal, which was a huge, huge change. And with this event, we saw the outbreak of this disease, sea star wasting disease, that affected many different species of sea stars, but in particular, this species, the sunflower sea star, Pycnopodia helianthoides. And the disease sort of attacks the connective tissue of these animals, and they sort of pull themselves apart and waste away. That's why it's called sea star wasting. I'm sure a lot of people on the call have tracked all this because obviously it's been huge news for a while now. And interestingly, just a few months ago, a Nature paper was published that we think definitively identified what this disease was. It was a bacteria in the kind of bacteria family called Vibrio, which is a type of bacteria that has a lot of negative mortality and disease-inducing effects in other shellfish and other marine animals. There's a lot of questions about this still in terms of, it seems like it was here before the heat wave, but how long was it here for? Why did the heat wave activate it? How does that work? And then questions about, is there potential for sea stars to develop resilience to this disease? Because we now kind of, after losing the sea stars, which I'll talk about those figures in a second, we now understand how important these animals were in the system. We knew that they ate adult purple sea urchins. It's kind of an artist's rendering of this here on the left, and that they were important. And then obviously we've had kelp forests and healthy abalone populations after the otters disappeared. So these were a redundant predator in the system. But I think what we're appreciating more now, and a lot of science has been done on this, is that these animals very quickly on eat baby and juvenile sea urchins as well, not just adults. So these are larval Pycnopodia, and then this is post-settlement Pycnopodia, and then this is early juvenile, and you can see it's already very actively preying on the sea urchin. So they were really helping to control all stages of the purple sea urchin life cycle, and had a huge impact in maintaining balance in this system after losing the sea otters. And what I recently went to a sunflower sea star restoration workshop where this was kind of the number that was put out there. 5.75 billion sunflower sea stars have perished on the West Coast since 2013, which is sobering. That's just a gigantic number. I didn't know that we had close to 6 billion sunflower sea stars on the West Coast, let alone that 90% of them have perished through this disease. So 90% loss on the West Coast, 99% locally in Sonoma and Mendocino counties. And I'm sure folks have probably seen this figure. This is just showing what the satellite imagery of kelp canopy looked like. This is from 2008, and then when the heat wave hit 2014. And so there were acute impacts on kelp from the heat wave itself, but we haven't really seen much recovery since this period of time. And the reason for that is because of the dramatic expansion of the purple sea urchin population. because we've lost all predators that helped regulate the population of these animals previously. So, like I said, a 99% loss of sunflower sea stars in Snow and Mendocino County, a 60x increase, 60 times increase in purple sea urchin populations, 95% loss of kelp biomass. And very importantly, an 85% decline in abalone stocks in Northern California since 2014, which is another huge deal. And the reason that we've seen the decline in abalone is that they can't find food. When we had healthy kelp forests, we had this abundance of really this huge subsidy of kelp biomass all up and down the coast. Abalone could kind of live in cracks and crevices, come out at night and reach for kelp fronds and find enough food and persist that way. And when we lost the kelp forests, we lost that subsidy, and we really started to also lose densities of other seaweed species as the urchin population has dramatically expanded. And so we've been seeing abalone coming out at weird times of the day when they normally aren't, desperately looking for food. And we've seen many, many thousands of emaciated, starving abalone in the wild, and these events of starving abalone washing up on shore under stress, especially when there's kind of big weather events. And they might have been able to deal with that before, but in their current state, it's harder and harder for them to do that. And then very importantly, what we're seeing and started seeing beginning in 2015 was close to zero reproduction of the red abalone in the wild. And that's because abalone need food to invest in reproduction. And when there isn't food, they don't make that investment. We've seen very, very few baby abalone coming into the system, which is a huge problem in terms of the sustainability of the population and the fishery. And many of you probably know this was the world's largest recreational abalone fishery in the entire world, and tens of thousands of people came from all over the state of California and all over the world to dive for this resource in what was a very well tightly managed fishery that had been here for thousands of years, kind of in the modern period, regulated by the state for decades, many, many decades. And the state decided to close the fishery in 2018, especially kind of seeing the data about the loss of the babies coming into the system. And just this summer, proposed a 10-year closure extension of the fishery to 2036, and is talking about a potentially indefinite closure. So this is a huge deal for many Californians who have a powerful connection to coming and diving here. Many generations of Californians have come here and taken advantage of this and have really fond memories of diving on beaches and being with parents and having this powerful connection to the beautiful coastline up here, all through kind of this activity of getting together and diving for abalone. But I would argue this really is the hugest impact. The hugest impact of this is on California's indigenous people. And this is a Kashia dancer dancing in a ceremony at Fort Ross. And it's really hard to put words to this in a kind of a quick talk like this, but abalone is incredibly important to the history and the culture of the Kashia people. This dancer here, you can see, has a necklace made of abalone shell. And this is kind of a headpiece that has abalone shell. Both of these have tremendous sacred importance and are used in ceremony that the Kashia are a part of. And these pieces are handed down within families from generation to generation and have incredible significance and meaning. The origin of the tribe itself is connected to abalone. There are many stories of abalone that are very central in Kashia culture. And you can see here, this is a basket piece that abalone was used many, many, many different ways and is an incredibly important resource to the Kashia people. And beyond kind of the stuff that's hard to fully describe, this was a staple food resource for the Kashia and for many, many other California's indigenous tribes. For thousands of years, this was a primary food in a way that Kashia families supported themselves for 12 millennia. And also, it was very importantly a way that generations shared knowledge and stories and taught ways of being with ocean resources. You had grandpa in the intertidal, grandma and grandpa teaching lessons to the grandkids about where do you harvest the abalone? How do you not take too much? Which areas do you let rest? And then teachings and lessons of at all the same time about abalone, seaweeds, stories of other marine life, important things that have been handed down generation after generation for thousands of years until 2018, when the state closed this fishery and made it illegal to harvest these animals, and really was a dramatic impact, and not just for Kashia, but for many of California's indigenous peoples. So from the tribe's perspective, the Kashia have seen these relatives be lost, and want to do everything in their power to kind of turn the tide on this, and not have these changes be permanent, and especially do everything in their power to not lose this relative, which is so important to the Kashia. So I'm going to switch over to a video that hopefully is going to be okay. If the audio is weird, you can't hear anything, please chime in. This is Severino Gomes, who's a Kashia tribal elder, former chairman of the Kashia Band of Home Indians. And what we're going to shift to is kind of what we're working to do about all these things, with a focus on a big part of this work, which is developing a tribally owned and operated abalone farm on Kashia land, which Severino is going to talk about here. So we'll launch right in.
What defines a hero? Is thank you.
Well, thanks. I appreciate this. Yeah, I'm with the Kashia of Stewart's Point, Pomo, but we consider ourselves Pomo, but Kashia also, in which, as far as we're concerned, we've been here forever. And basically, that's where I come from. One of my professors brought to the class attention an abalone farm that was down in Central California, around Monterey. It was the Cayucas abalone farm, which they started in 1968. I get to thinking, boy, that would be great if we can have something like that. Give back to so our people can do that. Being that we've lost access to all those resources over a period of time, that was one of our traditional foods, one of our main traditional foods. I put it right alongside the buffalo, like what actually the Sioux had. We would never get the whole coastline back, but we didn't need the whole thing, just a portion of it. Then as the years went by, the opportunity just presented itself with us acquiring coastal property, which gave us the opportunity to actually, for me, to go back and visit this again. Got a lot of support from our tribal members. Initially, when we started this, it was just from our people, to give us access back. But the more I looked into this, the more research I did, then I started to realize that, what was happening out there in the ocean with the abalone and other species, this is much bigger than we can handle if we try to go this alone. I finally realized, I said, we're going to have a lot of help to do this. So we reached out to other people, and to my surprise, everything just fell into place. Everything was just positive. Everybody we came in contact with in the academic area, state of California, Sonoma County, scientific people, Bodega Marine Lab, just really supportive of our project. With our project, we want to raise that not only for our people, but if it comes down to it, to restock the abalone in the ocean. The ocean's forming the ocean anyway. Nobody knows what that's actually going to do over the years. They can't repopulate themselves for some reason or another. We're willing to step in. I very rarely take a step back to look at myself. I didn't expect to be where I'm at right now. I thought I could just start this and stay in the background, but if you want to really make this happen, you got to be out front. Nobody else is going to do it, unless if you leave, you got to be out there. You got to be out there doing the footwork with a lot of help from others. I find if people really like what you're doing, you're gonna have no problem finding mentors. I have a lot of mentors. I mean, that's how I keep moving. That's how I keep going forward. We still have a lot of work to do. This will probably take a couple of years before we can actually, start actually farming abalone. Something at this scale is slow, so I had to learn to have patience. We had to get the land first. That was a process. Once we got the land, and then we started moving forward. this is a good beginning for us to actually give them an opportunity to start getting back to their traditional foods, which we've lost over the years. Anyone that believes in something is not impossible, and you don't have to know everything, but it's very important for you to find the people that do know. You don't have to be the smartest person. Just find some of the smartest people that make your idea comes a reality.
So, Severino very eloquently spoke about that and kind of what this means to Kashia, and hopefully that video played okay. So, he talked about two parts of what we're trying to do, and one is establishing a tribally owned and operated abalone farm. This is a picture of the cultured abalone farm in Santa Barbara. I actually worked for the company for 5 years before I came to work for the tribe. And this is what, producing abalone, one vision for what producing abalone might look like. Severino talked about restoring access of this traditional food to the Kashia, but the other part of that is playing a role in restoration of the abalone in the wild. And to do that, you have to have scientific capacity and divers that can go out and reintroduce the abalone and then track their success year after year. And so we are on this journey of putting the pieces together for the tribe to have both of these components and to play a leading role in this work with many other community groups up here on the North Coast. So we're fortunate to receive funding from NOAA for this project, a Tribal Scientific Alliance to Restore Red Abalone in Northern California's kelp forest ecosystem. And this project is focused on restoring a kelp forest in the Sea Ranch region of Sonoma County, which is definitely in Kashia territory. And the first name for this region was Tuleka'leo, which means many hummingbird trees, is the first name of the Sea Ranch area. And in particular, I'm working at this beach called Shell Beach, which actually has been a place that the Kashia have gathered marine resources for many, many thousands of years and have a particularly strong connection to. And also, we know that the Sea Ranch coastline historically was an abalone hotspot, that there was huge abalone biomass and huge kelp forests on this whole stretch of coastline. And now, of course, the kelp is gone and the abalone is dramatically declining. So what we're trying to do experimentally at this site is this is what it looks like from the surface today, taking this and restoring it back to this plentiful bull kelp abundance that we know used to be there. And the reason we picked this site is a couple. One, the abalone and kelp hotspot metrics that I talked about. We also looked at this site, kind of a satellite imagery of kelp forest canopy cover historically. And this site has always had a lot of canopy. And then this is recently, this is last year. Okay, this is last year. You can see here, I'm going to zoom in this little feature, which is this small kelp forest here. And what we've seen even since the heat wave is that there has been this small persistent kelp forest at this site. And And so the idea here, as I'll just show it again, as you guys can get a sense for the site. The idea here is that this site might be easier than some other locations to restore because of this persistent kelp forest that's been there. If you could remove the urchins and defend it, you might have a higher chance of having spores and papageals from that kelp forest repopulate the cove. And it's a small cove. It's not a super big area. This is a low tide, so normally it's kind of full with seawater. But if this is the scope of the cove, we have to completely restore in terms of the kelp that was there. And we're out this way with the tribe environmental staff doing a survey. So this just gives you a sense for what that site looks like. And what we're doing, like other folks on the North Coast have been doing, is starting by removing as many purple sea urchins as we can. So the tribe, this is, I should emphasize at the beginning here, this is a big collaboration with a lot of partners that the tribe's working with. UC Berkeley, Dr. Dan Okamoto's lab at Berkeley, the Noyo Center for Marine Science, Sheila Siemens, Greater Farallones Association, Sonoma State University, and then funding and logistical support from NOAA. But the first phase of this is focused on hiring commercial sea urchin divers to come down from the Fort Bragg area and remove as many purple sea urchins as possible. The idea being that we then start to see gradual kelp recovery if you can reduce the herbivory pressure of those animals. And so far, we've done 2 seasons of these removals. We've removed 100,000 pounds of purple sea urchin from just that small cove that I showed you. So just tremendous. It shows you how huge of an issue this is and how many purple sea urchins we have up and down the coastline here. This has been a great success these first 2 seasons, and I think we're going to have one more season of kind of high concentrated removals. And actually, the New York Times just yesterday published a story that featured Kashia talking about this work. So if you haven't checked that out, go take a look. A cool little piece talking about a lot of the work that's being done by lots of folks up and down the coast. But just a little pitch that came out yesterday. So super exciting. But a big part of this really is having the tribe take a leadership role in these efforts. We've hired commercial sea urchin divers to kind of put in this huge effort to remove as many as we can as fast as we can. But in the long term, we want to have the tribe itself manage this site and kind of really take the lead on this. So this has been a hugely rewarding part of this project is training Kashia tribal members to become scientific scuba divers. We've trained 6 tribal divers so far. I'll mention here Chris Elliott, Eli Scott, Ray LaRose, Esther Strub, Brian Pantanita, and Colin Carney. This is Chris and Araya this summer, finishing the AUS science course. And this is Brian Pantanita, the tribe's dive coordinator, who's kind of helping manage all this. And this has been a huge partnership with the Bodega Marine Laboratory, and hopefully just the first of a bigger roster of Kashia tribal divers that we're putting together to support this work. And the idea is that after we finish the big removals with the commercial divers, that the tribe kind of takes over the tending of this site in terms of getting out there every year, kind of removing smaller amounts of urchins as we kind of see new animals coming into the system to keep those densities low, and really taking the lead on being the caretakers of this site and kind of working with commercial urchin divers to kind of get skills and training and how you kind of do this effectively, obviously at a less intense level. But we're working towards that objective. And then also having the tribe take the lead, and we're training actually with UC Berkeley and the Greater Farallones Association to build these skills for the tribal divers, to have them be the ones that quantify kelp recovery and biodiversity recovery through time as we see the kelp forest hopefully recover after this big effort that we've been putting in to remove the urchins there. So the other half of all this is, of course, raising abalone and the effort to establish a tribal abalone farm that Severino talked about. And so this has been a partnership with the Bodega Marine Lab. I'm going to talk about different facets of this here. But I just want to kind of walk everyone through the abalone life cycle. And the idea is really to propagate these animals by the thousands to support restoration at Shell Beach and hopefully other locations in Kashia territory. So this is, you can kind of control this process. I did many abalone spawns working for the Cultured Abalone Farm and working with scientists doing a lot of work on this over many years. This is a spawning female that you can induce to release millions of eggs. You can then fertilize egg and sperm and create these larval abalone that swim for a week right about here. These adorable little swimming larvae that then settle into these juveniles, and you feed them diatoms and other microalgae in a kind of a carefully prescribed way. These are about large breadcrumb size animals. And then 3 years later, they switch to other feeds I'll talk about here at the end of the talk. And they're big enough to go back out in the wild. And that's what we're working towards as part of this project. And so this is kind of the master vision. You can call it phase 1, 2, 3, and 4, I suppose. Right now we're at phase 1, which is preparing an area for abalone reintroduction, and that's Shell Beach, because there's no point in putting the abalone back out if there isn't food for them. And that's a crucial consideration. They're not going to do well if there isn't a restored kelp forest. So you have to start there. Phase 2 is having tribal divers go out and collect wild broodstock that are going to be the first animals we experimentally spawn to create a restoration broodstock for putting back out in the wild. And we're actually working with the state of California right now to kind of get the permits in place for all this and focusing on populations of red abalone that are especially threatened. We've been out doing surveys and finding some areas where the abalone are very clearly completely surrounded by urchins, and there's no kelp, and sometimes they're even being kind of pushed on shore and getting exposed to the air for long periods of time, desperately looking for food. So kind of targeting those vulnerable populations first and rescuing some of the animals there that look like they're in big trouble for this effort. And then bringing those in to the Bodega Marine Laboratory, where the tribe has a shared lab space where we're doing a lot of this work. It's a really great space to be working. They're probably going to need a year to recover from the starvation conditions. I've done some work previously showing that they take a long time to recover when you do bring them in from the wild in kind of the conditions they're in now. So you got to give them lots of food, keep them nice and cold, and then probably after a year of conditioning, they're ready to spawn and you produce the babies. And 2 to 3 years after they're born, you put them out in kelp restored habitat. And then you keep this cycle going. This is something that we're working on with many partners and is kind of what it's all about in terms of abalone restoration. And, we're not starting from scratch. Thankfully, we have a lot of partners and have learned a lot from what's worked for white abalone, what's worked for green abalone restoration and red abalone restoration elsewhere in the state. And of course, the big difference is that we have to make sure we have restored food for the abalone that is particular to the challenge up here on the coast. But this is the big vision and the road we're on. And I just want to talk about, the tribe's ambition to build an abalone farm. We are now embarked on this mission. This is a rendering of an aquaculture farm. It's not the particular Kashia farm, but to vision what this farm could and should look like with some of the field leading marine engineers and an architecture firm and attorneys that are going to help the tribe deal with kind of all the permitting that will be required for this. But we are well on this road and a lot of exciting developments in the last couple of months. So stay tuned over the next few years as we continue to build out this vision, which we're very excited about. But it's important to point out that, marine labs like the Bodega Marine Lab and other labs on the coast, unfortunately, they're great places to have these partnerships and do work at, but they don't have the capacity to produce, tens to hundreds of thousands of abalone, which is really what we're going to need to support the wild population. You really have to have a dedicated facility to do this, and that's kind of a core part of what we're trying to do. This is the hatchery at the cultured abalone farm. This is what like a dedicated abalone hatchery would look like, and then you have grow out tanks. And so that's part of the visioning is what is the scale and capacity we need, and how should this facility come together. And importantly, from the outset, we're also talking with many partners about this facility supporting the culture of other resources that are essential for the kelp forest, like the conservation culture of sunflower sea stars, which many people are now working on breeding those for reintroduction into the wild as well. And then kelp. We're working with a lot of partners that are captively culturing kelp. Some folks at the culturing at the Bodega Marine Lab that's destined for outplanting as part of kelp restoration efforts. And they're hitting the same hurdle, which is the marine labs only really have so much space to scale this. And so we do have to have a dedicated place where there's capacity to culture these resources if we're going to have a chance at succeeding in the long term. And we really hope that the Kashia facility will serve that role. And just to show you, this summer we paid a visit to the California Academy of Sciences and the Kashia's environmental staff and saw the amazing work they're doing to culture Pycnopodia there, working out all the specifics of how you improve the efficiency of doing this. Because they're predators, you have to raise their prey all throughout their life cycle. So it's really resource intensive and complex, but we are forming a partnership with them to play a role in this. And it was really amazing to see juvenile sunflower sea stars that have been produced there. And longer term, we want to work with Cal Academy to kind of have this be a core part of this mission too, to kind of train and understand how you raise these animals and contribute to that work, and then work with the state and other groups to permit putting these animals back out in the wild when we're ready to do that, and maybe have Shell Beach be one of the first places that this happens, and then eventually expand these efforts elsewhere in Kashia territory. Okay, wrapping up here, I just want to talk about one cool project that we're kind of reaching some important milestones on and next steps on, which pertains to abalone aquaculture, which is how are you going to feed these animals? If you're going to raise many abalone, what are you going to feed them? Traditionally, abalone aquaculture on land would work by boats going out and harvesting boatloads of kelp, and you would bring that into your land-based tanks and you'd feed your animals. And unfortunately, that's probably not going to work in Northern California anymore because we've lost the kelp forests. So there's this important question of, what are the basics here of figuring this out? And so over the last few years, we've launched this project to think about kelp alternative feeds. And this was actually brought to the group by Severino, who was in the video I showed, who said, hey, I've come across some papers from Australia and New Zealand showing that they're using winery waste and making abalone feed. And it seems like it's working pretty well, and the abalone are growing pretty successfully. And so we thought to ourselves, well, why don't we try this in California with California abalone? Because we have hectares and hectares of vineyards up here in Sonoma County, and pretty much unlimited winery waste as far as the eye can see in all directions. So the winery waste is called grape pumice. It's after you press the grapes for juice, you have the leftover skins and seeds and stems and bits. You can grind that up into this kind of finer material, add different ingredients, and produce abalone feed. So we followed what the Australians did and wanted to test it with California abalone. This was a partnership with Moss Landing Marine Labs, Luke Gardner's lab at Moss Landing, the Food Science Department at UC Davis, and Dan Okamoto's lab at UC Berkeley, where we produced this first round of this feed, which looks like this, and we tested it against this. It's called AbKelp. This is kind of like an open market feed you can buy. It's produced in Mexico. And there are these other feeds, in other parts of the world, South Africa, Asia, other places where you could buy these feeds. There's kind of question, they're coming a long way. They're expensive. There's questions about their sustainability. So we wanted to produce something in-house and just see how that would do against something you could buy as a potential alternative feed. And this is what the tribe's aquaculture culture system at the Marine Lab looks like. I designed the system and helped build it a few years back, and this is kind of co-administered between Kashia and UC Berkeley at the Bodega Marine Laboratory. So we have these floating aquaculture baskets. This is Brian Antonito, who's the tribe's dive coordinator now, but he started as an aquaculture technician. And so we've got these baskets with juvenile abalone that we purchased from the cultured abalone farm in Santa Barbara. And then we have our experimental feeds here, and we see how well they do on the feeds. And there's a lot of results we've gotten from these experiments that I don't have time to go into today, but I want to just show kind of one main result. So this was this big experiment we ran for 120 days. We've got growth rate here on the left, and we've got days of the experiment on the right. The colors here are the experimental diets we made, and then AbKelp is here on the bottom. These are the percentages of grape pumice in the feed, and then V here means vegan, so there was no animal protein used in these diets. Whereas these ones on the top here, we did use fish meal because that's what the Australians sort of did, and we wanted to just see how we compared to their results. So what you'll see here is they kind of start out with similar growth rates, but very quickly they take off on our experimental diets. And we were really impressed to see this. I don't think we were quite expecting this. This is more than double the growth rate on these diets and more than triple the growth rate on these diet groups up here compared to AbKelp. So incredibly exciting. And where we're going next is to kind of continue refining this, kind of a second draft of how you do this. And I'm very excited to have a partnership and be working with this person, Dr. Andrea Alfaro, who's the incoming new director of the Bodega Marine Laboratory. But before she came out to California and is soon going to be in that job. She was in New Zealand for a very long time doing aquaculture feeds research and specifically focusing on abalone aquaculture feeds development, kind of developing a lot of really cool ways that you increase the water stability and kind of digestibility and accessibility of the feeds. And believe it or not, she had been doing work on great pumice-based feeds too. So we've got a whole kind of second draft of these feeds that we're very excited to test out, and we're really impressed by the thought that's already gone into a lot of this, and really excited for where this could kind of take the whole project moving forward. Okay, so that was a big overview, and obviously there's a lot of details within all that, and I'd be happy to answer some questions here shortly, but I want to just conclude with a video that was produced by Brian Piantanita, the tribe's dive program coordinator. This is a short clip. All the footage in this video was taken from the Kashia divers training and subsequent survey work we've been doing. And this is a video to kind of that we're sharing with the tribal community soon to see if we can recruit more tribal members to become part of the diving program. And I think it tells the story well in a short period of time. So I'll just play this and then we'll wrap up and hopefully have time for some questions. So thanks for your attention.
Sonoma Coast, sacred.
It's higher depth so you guys can see this. It's clean if I don't do that. All right, here we go.
Kashia land that is an icon of California's beauty and home to an extraordinary dynamic ecosystem where the sea meets the rugged, resilient coastline. In the summer of 2014, an ocean heat wave devastated the coastline, triggering the loss of sea stars and causing a massive explosion in the population of purple sea urchins. For hundreds of years, this area has had vast, lush kelp beds thriving with diversity. Urchins eat kelp, and kelp forests in Kashia territory have been eaten away by the overabundance of urchins. 95% of the kelp forests have been lost in a decade, and without the abundance and food provided by this kelp, there is a major imbalance in the ecosystem. Red abalone, so important to Kashia culture and history, and a staple traditional food, is in big trouble. Abalone feed on kelp to survive, and the loss of kelp forests is too much for abalone to handle, leading to many starving abalone and an 85% decline in the population. If we take action, these changes don't have to be permanent. We can act as a community to restore kelp and abalone. The Kashia environmental and cultural teams are working hard to restore the tribe's role as caretakers of the coast, and are looking for tribal members to support work restoring abalone and kelp forests, incorporating traditional stewardship practices. The health of the community is one with the health of the land and water. Scuba diving can provide unique access to the undersea world in a way that most don't get to see. Kashia now has a team of 6 divers who are working to support kelp and abalone restoration for the first time in the tribe's history. We are looking for more interested divers or those interested in getting involved in other ways. This opportunity is available to anyone over the age of 18, regardless of your background or experience. If you are interested in conserving the ocean world or diving, we want to get in touch. Kashia divers are getting state-of-the-art training from some of the most respected dive safety professionals on the California coast. We are looking for more tribal members to take advantage of this unique opportunity. The team will be playing a key role in kelp recovery and our abalone restoration efforts. Healing our lands and our waters is not separate from healing ourselves. Healing ourselves is not separate from healing our lands and our waters.
All right, well, that does it for me. Thanks for your attention, and happy to answer some questions if we've got time.